Good day everyone! Welcome again dito sa klase natin sa Theory of Structure CE325. So for today, we're going to discuss the continuation of our Unit 2, which is all about the analysis of external reactions and internal stress resultants of statically determinate structures. And for today's discussion, we will focus on trusses. So let's start. When we say truss, so it is an assemblage of straight members connected at their ends by flexible connections to form a rigid configuration. Because of their light weight and high strength, trusses are widely used and their applications range from supporting bridges and roofs of buildings up to being support structures in space stations. Modern trusses are constructed by connecting members which usually consist of structural steel of aluminum shapes or wood struts to gusset plates by bolted or welded connections. In analyzing truss, it can be classified as plain truss and space truss. When we say plain truss, all the members of a truss and the applied loads lie in a single plane. Plain trusses are commonly used for supporting decks of bridges and roofs of buildings. So the figure shows a typical framing system for a roof supported by a plain trusses. So in this case, two or more trusses are connected at their joints, which is called purlins. That is to form a three-dimensional framework. The roof is attached to the purlins, which transmit the roof load as well as their own weight to the supporting trusses at the joints. Because of these applied loadings act on each truss in its own plane, the truss can be treated as plain trusses. Here are some of the most common type of bridge truss. So we have Howitt truss, Pratt truss, Warren, Parker, K-truss, and Baltimore. Next, we have the common type of roof truss. So we have the King Post truss, Howitt truss, Pratt truss, Warren truss, and Pink truss. This pink truss is a plain truss that is a compound truss. So kadalasan class ng pink truss, may hinge lang sila dito. So it is two simple truss that is connected by a hinge. That is a pink truss. Majority of trusses can be analyzed as plain trusses. However, there are some truss systems such as transmission towers and lattice domes that cannot be treated as plain trusses because of their shape, arrangement of members, or applied loading. Such trusses are called space trusses and are analyzed as three-dimensional bodies subjected to three-dimensional force system. Now let's move with the assumption in the analysis of trusses, particularly in plain truss. So the analysis of trusses is usually based on the following simplifying assumption. First, all members are connected only at their ends by frictionless hinges in plain trusses and by frictionless ball and socket joints in space trusses. Second is that all loads and support reactions are applied only at the joints. And lastly, the centroidal axis of each member coincides with the line connecting the centers of the adjacent joints. So the reason for making this assumption is to obtain an ideal truss, whose members are subjected only to axial forces. Since each member of an ideal truss is connected at its ends by frictionless hinges with no loads applied between its ends. So the member would be subjected to only two forces at its ends. Since the member is in equilibrium, the resultant force and the resultant couple of the two forces, FA and FB from figure A, must be 0. That is, the forces must satisfy the three equations of equilibrium. So again, from figure A, we can see that in order for the resultant force of the two forces to be 0, the two forces must be equal in magnitude but with different or opposite senses. For their resultant couple to be also equal to 0, that is summation of moment equal to 0, so the two forces must be collinear. That is, They must have the same line of action. Furthermore, since the centroidal axis of each truss member is a straight line coinciding with the line connecting the centers of the adjacent joints, the member is not subjected to any bending moment or shear force and is either in axial tension, so being elongated as shown in figure B, or in axial compression being shortened shown in figure C. So such member axial forces determined from the analysis of an ideal truss are called primary forces. Kapag may shear naman at bending na yung i-consider, tinatawag na naman natin yun na secondary forces. Next, external supports and internal connection. So these are the most common type of support for truss. So we have a roller and the hinge. So kagaya lang to nung nandun sa beam natin. So this is the symbolic representation for roller and this is for the hinge. So sa reaction natin sa roller, isa lang siya. Sa hinge naman, dalawa. Okay, so next naman, dito sa internal connection, so we have the joint. Joint connects the member of a truss with each other. It transfers the load from one member to another member. Now again, to be in equilibrium, so dapat equal lang sila ng magnitude but of opposite direction. Now, let's move with the stability and determinacy of a truss. Here, we have a criterion established for internal stability. When the member is less than 2 multiplied by the number of joints minus the number of reactions, the truss is internally unstable. Now, if the number of members is greater than or equal to 2j minus r, so the truss is internally stable. So again, M is equal to the number of members, R is the number of reactions components, B plus R, so that is the total of unknown elements of the entire system. So J is the number of joints. So note lang class that it is very important to realize that although the foregoing criterion for internal stability is necessary, it is not sufficient to ensure internal stability. So a truss must not only contain enough members to satisfy the M is equal or greater than 2j minus r condition, but the members must also be properly arranged to ensure rigidity of the entire truss. Each joint is connected to the rest of the structure by at least 2 non-parallel members, and each portion of the truss must be connected to the remainder of the truss by connections capable of transmitting at least 3 non-parallel and non-concurrent force components. Now, here's the criteria for the static determinacy. Indeterminacy and instability of general plane trusses containing M members and J joints and supported by R, which is the number of external reactions. So for the analysis, we need to determine M, the member forces, and R, external reactions. That is, we need to calculate a total of M plus R unknown quantities. Since there are J joints, and we can write two equations of equilibrium, which is the summation of forces horizontal and summation of forces vertical for each joint. So the total number of equilibrium equations available is only 2, kaya 2J. So if the number of unknowns M plus R for a truss is equal to the number of equilibrium equations, which is 2J, so it only means that M plus R is equal to 2J. So yun nga, ibig sabihin lang nun that all the unknowns can be determined by solving the equations of equilibrium and the truss is statically determinate. So if a truss has more unknowns, which is yung M plus R natin, then the available equilibrium equations, 2J, that is M plus R is greater than 2J, all the unknowns cannot be determined by solving the available equations of equilibrium. Such a truss is called statically indeterminate. Statically indeterminate trusses have more members and or external reactions than the minimum required for stability. So the excess members and reactions are called redundants. And the number of excess members and reaction is referred to as degree of static indeterminacy. So yun yung DE natin, which can be expressed as DE is equal to M plus R minus 2J. So if the number of unknowns for a truss is less than the number of equation of joint equilibrium, that is M plus R is less than 2J, the truss is called statically unstable. So the static instability may be due to the truss having fewer members than the minimum required or internal stability, or due to an insufficient number of external reactions, or both. So the conditions of static instability, determinacy, and indeterminacy of plane trusses can be summarized as follows. So this one. So let's have an example. So for this given truss, meron tayong 13 members, 3 reactions, and 8 na joints. So, yung members class, so ilang piraso lang yung kanyang mga bars. And then, yung joints naman, so ilan yung connection nila. So, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay? So, let's check the internal stability of this truss. So, we have M is greater than or equal to 2J minus R. So, ilan yung member natin? That is 13. So, 2, fixed lang naman na 2 ito, multiplied by 8 minus 3. So, again, class, kaya ito naka-fix na 2 kasi dalawa lang naman yung equations of equilibrium natin na magagamit dito. So, yan na nga. So, we have 13. So, this is 16 minus 3. So, makuha natin is 13 is equal to 13. So, it only means that this given truss is internally stable. So, let's check naman yung kanya external determinacy. So, for external determinacy, we have M plus R is greater than or equal to 2J. So, ilay members natin, 13. Ilay reactions natin, 3. Ilay joints, 8. So, solving this one, 16 ang makukuha natin is equal to 16. So, that means that this given truss is statically determinate. So, here's another example, a scissor truss. So, this truss has 10 members and 3 reactions. The number of joints is 7. So, that's 1, 2, 3, 4, 5, 6, and 7. So, let's check its internal stability. So, we have, substitute lang natin siya class dito. So, we have 10 is that greater than or equal to 2 multiplied by 7 minus 3. So, ang ma-solve natin class is that yung M natin, that is 10, and yung 2J minus R natin, that is 11. So, ibig sabihin lang nun, 10 is less than 11. So, kapag ka less than, the truss is internally unstable. So, kahit unstable siya, check naman natin yung kanyang external determinacy. So, substitute lang natin ulit. Dito sa M plus R is greater than or equal to 2J. So, we have 10 plus 3 is equal to 2 multiplied by 7. So, ang masasolve natin dyan, class, is 13. So, 13 is less than 14. So, ibig sabihin lang, so, statically unstable talaga yung truss natin, kahit external and internal. So, here's another example. So, from the given truss shown, the number of member is 19, the number of reaction is 5, and the number of joint is 12. So, let's check its internal stability. So, substituting these values dito sa may general rule natin, so we have 19 is equal to 19. So, the truss is internally stable. Now, let's check the external determinacy. So, using this general rule na to, so we have M plus R is greater than or equal to 2J. So we have 19 plus 5 is equal to 2 multiplied by 12. So that is 24 equal to 24. So our trust is externally determinate. So pag sa trust class, dalawa yung pagsosolve na gagawin natin. So let's check the internal stability and external determinacy. Next, we have computation of support reactions and internal forces. We can use method of joints and method of sections. In the method of joints, the axial forces in the members of statically determinate truss are determined by considering the equilibrium of its joints. Since the entire truss is in equilibrium, each of its joints must also be in equilibrium. So, it must satisfy two equilibrium equation, that is the summation of forces horizontal is equal to 0 and the summation of forces vertical is equal to 0 in order for the joint to be in equilibrium. The method of joints consists of selecting a joint with no more than two unknown forces acting on it and applying the two equilibrium equations to determine the unknown forces. So the procedure may be repeated until all the desired forces have been obtained. So the method of joints proves to be very efficient when forces in all the members of a truss are to be determined. However, if the forces in only certain members of a truss are desired, the method of joints may not prove to be efficient because it may involve calculation of force in several other members of the truss before a joint is reached that can be analyzed for a desired member force. So the method of sections enables us to determine forces in the specific members of trusses directly without first calculating many unnecessary member forces as may be required by the method of joint. In the method of section, there are only three equilibrium equations available, so they cannot be used to determine more than three unknown forces. Therefore, in general, sections should be chosen that do not pass through more than three members with unknown forces. So here's the procedure in analyzing plane trusses using method of joints. So first is to verify the stability and determinacy of the structure. The truss is stable and determinate, then we will proceed to the next step, which is to determine the support reactions in the truss. So next is to identify the zero force members in the system. So this will immeasurably reduce the computational efforts involved in the analysis. So next is to select a joint to analyze. So at no instant should there be more than two unknown members forces in the analyzed joint. So next is to draw the isolated free body diagram of the selected joint and indicate the axial forces in all members meeting at the joint as tensile. So if this initial assumption is wrong, the determined member axial force will be negative in the analysis, meaning that the member is in compression and not in tension. So next is to apply the two equations of equilibrium. So we have the summation of forces horizontal and vertical to determine the member axial forces. And lastly, continue the analysis by proceeding to the next joint with two or fewer unknown member forces. So now let's have example number 1. Determine the force on each member of the truss shown. Use method of joint. So as discussed, the first step is to determine the determinacy and stability of the given truss. So the truss is composed of 7 members and 5 joints and is supported by 3 reactions. So let's check first its internal stability. So for the internal stability, so we have M is greater than or equal to 2J minus R. So number of member is 7. So 2 multiplied by the number of joints, which is 5, minus R, which is 3. So we have 7 is equal to 7. So the given truss is internally stable. Now let's check the external determinacy of the trust. So we have M plus R is greater than or equal to 2J. So M is 7, reaction is 3, is equal to 2 multiplied by J, which is 5. So we have 10 is equal to 10, meaning to say that this trust is statically determinate. So we can proceed to the next step. So in this given trust, here we could start at joint E since joint E has two unknown non-collinear forces, FCA and FDE, acting on it. We can begin the method of joints without first calculating the support reactions. Ngayon naman, from the dimensions of the truss, we find all the inclined members have a slopes of 12 is to 5. So let's focus our attention now on joint E. So taking summation of forces horizontal is equal to 0 to the right as positive. So we have 0 is equal to 25 minus FTE multiplied by its slope na 5 over 13. So solving FDE, we have 65 kilonewton which is in compression. So next, taking summation of forces of vertical is equal to 0 going up as positive. So we have 0 is equal to FDE multiplied by its slope, which is 12 over 13, plus FCE minus 30. So solving FCE, we have 30 kilonewton which is in tension. So next, we consider the equilibrium of joint C. So, applying summation of forces horizontal equal to 0, so we obtain FCD, which is 50 kilonewton in compression. Now, taking summation of forces vertical is equal to 0, so we could obtain FCA to be 30 kilonewton, which is in tension. So, next naman, let's focus on joint D. So, both of the unknown forces, FAD and FBD, acting at this joint have inclined directions. So, we draw the free body diagram of this joint as shown and determine the unknown by solving the equilibrium equations simultaneously. So, since meron tayong two unknowns dito, may kaka-generate naman tayo ng two equations. So, possible na ma-solve natin talaga yung unknowns. So, taking a summation of forces horizontal is equal to 0. So, we have this equation, FBD multiplied by the slope na 5 over 13 minus FDA, its slope na 5 over 13 then is equal to negative 75. Now, taking a summation of forces vertical, we could derive this equation, negative FDB 12 over multiplied by its slope 12 over 13 minus FDA 12 multiplied by its slope na 12 over 13 is equal to 60. So using class hour calculator, could easily solve FDB and FDA. So ang kailangan niya lang gawin is to click modes, then number 5 for equation. Then click 1 since meron tayong 2 unknowns dito. So, for equation 1, FDB natin, so that is, yun yung gagamitin natin sa A, FDB. Then sa B naman, itong FDA. Then sa C, itong ating constant. So, we have 5 over 13. Then equal nyo lang, equal. Tapos, minus, since minus to, 5 over 13 ulit, equal lang. Then, negative 75 equals. So, next, dito tayo sa pangalawang equation. So, we have negative 12 over 13 equals. Then, negative 12 over 13 ulit. 12 over 13 equals. Then, 60 equals. click lang natin equal. So, ang x natin or yung ating FDB, that is negative 130. So, ibig sabihin lang nun class, dahil nag-negative siya, so yung assumption natin na tension siya, so compression siya dapat. Itong FDB. FDB. So, next naman, click lang natin ulit yung equals. So, yun naman yung y natin. Ito yung ating DA. So, that is 65. So, 65 kilonewton in tension. So, next, so by considering the equilibrium of joint B in horizontal direction, taking summation of forces horizontal, we can obtain FAB. So, FAB is 50 kilonewton in tension. So, having determined all the member of forces, we apply the remaining equilibrium equation. Summation of forces vertical is equal to 0 at joint B. So, for us to calculate the support reaction, RBY. So, from here, we could solve RBY is equal to 120 kilonewton. So, ang direction niya is taas. So, now, let's solve the reaction at joint A. So, applying summation of forces horizontal is equal to 0. So, we could solve RAX. So, that is 75 kilonewton going to the left. And then, by taking summation of forces vertical is equal to 0 going up as positive. So, we have RAY is equal to negative 90 kilonewton. So, ibig sabihin lang nun, yung assumption natin na RAY dito, since pataas siya, diba, negative yung lumabas. So, ang dapat na direction niya is pababa. So, kompleto na tayo, class, ng mga na-compute na forces on each member. Magkaroon lang muna tayo ng checking. So, using the three equations of equilibrium. So, taking summation of forces horizontal is equal to 0. So, we have 25 plus 50 minus RAX. So, yung RAX natin is 75. So, 25 plus 50 minus 75. So, 0 is equal to 0. Ibig sabihin, yung horizontal forces natin is in equilibrium. So, next naman, taking summation of forces vertical is equal to 0. So, ano yung mga papasok dyan? So, we have itong RAY, RBY, and 30 kilonewton. So, yung 30 kilonewton natin, negative yan kasi pababa. Yung RAY naman natin, so, na-compute natin siya kanina, na pababa din siya, kaya siya negative. So, dito class, we have 0 is equal to negative 90 plus 120 minus 30. So, 0 is equal to 0. So, yung mga vertical forces natin is also in equilibrium. So, next naman, taking summation of moment at point B is equal to 0, counterclockwise as positive. So, we have 0 is equal to RAY multiplied by its moment arm na 5 minus 50 multiplied by 6 minus 25 multiplied by 12 plus 30 multiplied by 5. So, we have 0 is equal to 0. So, pati dun sa mga moment or couple ay in equilibrium tayo. So, tama yung mga na-compute natin na internal forces and reactions. So, next naman, let's have the procedure for the analysis of trusses by method of section. So, first, we must check the stability and determinacy of the truss. So, if the truss is stable and determinate, then we can proceed to the next step. So, the next step is to determine the support reactions in the truss. Next naman is to make an imaginary cut through that structure so that it includes the member whose axial forces are desired. The imaginary cut divides the truss into two parts. So, next naman is to apply forces for each part of the truss to keep it in equilibrium. Then, next is to select either part of the truss for the determination of member forces. And last, apply the conditions of equilibrium to determine the member axial forces. Now, let's have an example. So, here we have a truss that is supported by a hinge at joint E and a roller support at joint A. A 120 kN concentrated load are applied at joint F, G, and H. At joint I, a 60 kN load is applied. Now, we are asked to determine the forces in members as CD, DG, and GH. So, we are asked to determine this force members by method of section. Now, before we proceed sa ating computation, let us first determine the stability and determinacy of our given truss. So, the truss is composed of 15 members and 9 joints and is supported by 3 reactions. So, para malaman natin kung internally stable siya, we have M is greater than or equal to 2J minus R. So, substituting these values and compute na din natin. So, we have 15 is equal to 15, meaning to say the given truss is internally stable. So, next for external determinacy naman, using this one, M plus R is greater than or equal to 2J. So, substituting again these values. So, we have 15 plus 3 is equal to 2 multiplied by 9. So, that will give us 18 is equal to 18. So, that is statically determinate. So, we could proceed to the next step. To start our computation, the first step is to analyze the given truss, where we will cut it. Of course, dun tayo magka-cut, malapit dun sa required. So here, we pass section AA through the 3 members of interest, CD, DG, and GH, cutting the truss into 2 portions and considering A, CG, and cutting the truss into 2 portions, A, C, G, E, and D, H, I. So, to avoid the calculation of support reactions, we will use the right hand portion, DHI, to calculate the member forces. So, here's the pre-body diagram of the portion of DHI of the truss as shown. So, all 3 unknown forces, FCD, FDG, and FGH, are assumed to be tensile and are indicated by arrows pulling away from the corresponding joints in the diagram. So, the slope of the inclined force FTG is also shown in the pre-body diagram. The desired member forces are calculated by applying the equilibrium equations as follows. So, taking summation of moment at D counterclockwise as positive. So, we have 0 is equal to negative 60 multiplied by 40 plus FGH multiplied by its moment arm na 3. So, we have GH is equal to 80 kilonewton, which is in tension. So, next, taking summation of forces up vertical is equal to 0 going up as positive. So, we have 0 is equal to negative 120 minus 60 plus FDG na may slope na 3 over 5. So, solving this one, we have FDG is equal to 300 kilonewton, which is in tension. So, next naman, kulang natin? So, ang kulang na lang natin is yung ating FCD. So, taking summation of forces horizontal is equal to 0, going to the right as positive. So, we have 0 is equal to negative 80 minus FCD plus 4 over 5 multiplied by 300. Solving this one, we have FCD is equal to negative 320 kilonewton. So, negative siya, ibig sabihin, mali yung assumption natin na tension siya. So, that is 320 kilonewton compression for FCD. So, we already solved all the unknown. Now, let's check our computations by taking summation of moment at joint I. So, this must be in equilibrium. Equal dapat sa 0 ang makuha natin. So, taking summation of moment at I is equal to 0, counterclockwise as positive. So, ano ni papasok dyan? So, we have 120 multiplied by its moment arm na 4 minus 320 multiplied by its moment arm na 3 minus 4 over 5 multiplied by 300 multiplied by its moment arm na 3, then negative 3/5 multiplied by 300 multiplied by its moment arm na 4. So, makuha natin dyan class is 0. So, tama yung mga nakuha nating internal forces sa FGH, FEG, and FCD. Since 0 yung nakuha natin, in equilibrium sila. Okay? So, we have here another type of plane truss. So, this is the compound truss. A compound truss consists of two or more simple trusses joined together. So, here, method of joints and method of sections can be used individually for the analysis of compound trusses. However, the analysis of such trusses can sometimes be expedited, mapapabilis niya, by using a combination of the two methods. So, pwedeng dalawang method ang gamitin natin para, yun nga, mas mapabilis ang ating computation. So, let's have here an example. So, example number 3, determine the force in each member of the pink truss shown. The pink truss shown is a compound truss formed by connecting two simple trusses, ACL and DFL, by a common joint L and a member CD. So before we proceed with our computation, let's check first its determinacy and stability. So the truss contains 27 members and 15 joints and is supported by 3 reactions. So let's start by checking its internal stability using this equation. So is it M is it greater than or equal to 2j minus r? Substituting this value, so we have 27. Is it greater than or equal to 2 multiplied by 15 minus 3? So that will give us 27 is equal to 27. That means the given truss is internally stable. So next, let's check its external determinacy. So is M plus R, is it greater than or equal to 2j? So substituting these values, we have 27 plus 3 is equal to 2 multiplied by 15. So we have 30 is equal to 30. So it only means that the given truss is statically determinate and we can proceed to our next step, and that is the computations. So in this given truss, it is advisable to solve first for the reactions. So the reactions at support A and F of the truss as computed by applying the 3 equations of equilibrium. So we have it here. So taking summation of forces horizontal is equal to 0. So wala naman tayong given horizontal forces or inclined forces. So RAX is equal to 0. Now, taking summation of moment at point F, joint F is equal to 0, counterclockwise as positive. So, we have 50 multiplied by its moment arm na 2, 50 multiplied by its moment arm na 4, plus 50 multiplied by its moment arm na 6, plus 50 multiplied by its moment arm na 8, plus 50 multiplied by its moment arm na 10, 50 multiplied by its moment arm na 12, 50 multiplied by its moment arm na 14 minus RAY multiplied by its moment arm, which is 16. So we could solve RAY, that is 175 kilonewton. So next naman, by taking summation of forces of vertical, we can solve RFY. So we have 0 is equal to RAY plus RFY minus 50 multiplied by 7. 1, 2, 3, 4, 5, 6, 7. So we have RFY is equal to 175 kilonewton. So next, now considering joint A, which has only two unknown forces, FAB and FAI, acting on it, so by equations of equilibrium of the forces acting at this joint, we obtain that FAI is equal to 391.31 kilonewton, which is in compression, and FAB is equal to 350 kilonewton, which is in tension. For the slope used for FAI, so we can use this one 4, and then yung kalahati na to 8, diba? So that is 1 vertical, 2 horizontal, and its resultant, which is square root of 5. So next step is to consider joint I. The pre-body diagram of joint I is shown. Member BI is perpendicular to members AI and IJ, which are collinear, so the computations of member forces can be simplified by using an x-axis in the direction of the collinear members. So here, we could solve FAI and FIJ. So taking summation of forces vertical, and taking summation of forces horizontal. So for FAI, we have 44.72 kilonewton, which is in compression, and FIJ is equal to negative 368.95 kilonewton, which is in compression. So after that, we can consider joint B. So using conditions of equilibrium, we can solve FBJ, which is 50 kilonewton in tension, and FBC, which is 300 kilonewton in tension also. So again, ito ang ating compound thrust. So ito na yung class yung mga na-solve natin na forces. So mapapansin ninyo, if we continue using a method of joints at joint J, there will be 3 unknowns. Kapag ka naman sa C, ito sa C, 3 din. So, best thing to do is to use the method of section. So, ang tanong dito, saan tayo magkakat para pag nag-moment tayo dito sa L, FCD lang ang magiging unknown. So, dito class, ito yung best location kung saan dapat tayo mag-cut. Now, the pre-body diagram of the portion of the truss on the left side of section AA is shown here. So, we determine FCD by summing moments about L. So, the point of intersection of the lines action FGL and FKL. Kasi kung dito tayo class magte-take ng moment, so ang mangyayari, 3 pa di unknown natin. Since pwede naman tayo mag-take ng moment dito sa point L, mawawala pa itong FKL and FGL. Ang magiging unknown lang natin is FCD. So, solving FCD by taking summation of moment at point L, so we have 200 kilonewton FCD, which is in tension. Since meron na tayong FCD, we could proceed our computation sa joint C. So, at joint C, there are only 2 unknowns, FCG and FCJ. So, these forces can be determined by applying 2 equations of equilibrium to the pre-body of joint C as shown here. So, dito class, we have 2 equations and 2 unknowns. So, again, para mas madali natin itong masolve, gamitin natin calculate natin. So, again, click lang natin yung mode, then number 5 para sa equation, 1 para sa 2 equations, 2 unknowns. So, ang A natin dito class is itong FCJ, ang B natin is itong FCG, and then yung C natin, that is the constant. So, for our first equation, so ang A natin dito ay 2 square root of 5. Then equals, then yung B naman natin ay 4 over 5. Ang constant natin ay 0 equals. So, next equation na tayo, this one. So, ang A natin is ito, negative 1 over square root of 5. Then, equals, yung B natin ay 3 over 5. Equals, ang constant natin ay 100. Equals, then equals. So, ang X natin dito, class, ay negative 89.5 kilonewton. So, dahil negative yung nakuha natin, ibig sabihin, yung assumption natin kanina na intention siya, dapat siya ay in compression. So, next naman, yung FCG. So, ang kailangan lang natin gawin ay i-click lang ulit yung equals. So, for FCG, we have 100 kilonewton. Since positive siya, so tama yung assumption natin na siya ay in tension. So, eto na class yung mga na-solve natin na mga forces on each member. Itong lahat ng may kulay red. Ngayon class, next thing to do is to consider joint J, K, and G. So, similarly, by successively considering the equations of joints J, K, and G in that order, we can determine the following. So, una, consider natin joint J, makakakuha tayo ng FJK and FJG. Then, next is i-consider natin joint K, makakakuha tayo ng FKL and FKG. Then, lastly, consider natin yung joint G, masosolve natin itong FGL. Ngayon, class, ito yon. So, for FJK, ang makukuha nyo dyan is 346.6 kilonewton in compression. So, ito pagpraktisan nyo kung same ba yung makukuha nyo dito sa ililista natin. So, FGJ, 50 kilonewton which is in tension. FKL, which is 324.21 in compression. FGK is equal to 44.72 kilonewton in tension. FGL is equal to 150 kilonewton which is in compression. Since the geometry of the truss and the applied loadings are symmetrical about the center of the line of the truss, so its member forces will also be symmetrical with respect to the line of symmetry. So it is therefore sufficient to determine the member forces in only one half of the truss. So the member forces determined here for the left half is the same dito sa right half natin. So, ibig sabihin lang nun class, we don't need to solve the other half kasi parehas lang tayo na makukompute ng mga forces. So, kung ano yung mga nakuha natin dito sa AB, same lang doon sa makukuha natin sa FE. Kung ano yung nakuha natin sa IB, so same lang siya sa OE. Ganun. Parehas lang sila. So, that's it class. That's how we solve for the member forces if the given is a compound truss. So, next naman na discussion natin will be all about shear and moment sa beams and plane frame. So, this topic will be the last part of our Unit 2. So, thank you class for listening. So, again, reminder ko lang, pwede nyo i-pause yung video para makapag-solve din kayo.